Right, hello everybody and welcome to today's session. So this webinar is something we run every couple of weeks. The intention is to provide a bit of a quick start session to people that are new to Humio. You've very likely been invited to this session because you've shown interest in the product or the platform. Maybe you've signed up for a demo, downloaded the product, signed up for an account on our cloud service. So a couple of ground rules about the sessions. We run this in a webinar format, so you guys are all muted. What I will say is if you have any questions throughout the session, please do feel free to use the Q&A section in GoToWebinar. So I will keep an eye on that through the session and as much as possible answer those questions as they come up. Feel free to drop them in whenever you're ready. So what I want to do over the next 30 to 40 minutes is give you a little bit of a run through on Humio of all the resources that are available to you. This is to help shortcut some of the learning that you're going to have to do as you look at Humio and help you find access to the information that you need. I'm also going to give you some details on how you can interact with us if you want to ask technical questions, if you want to get involved in the Humio community side of things. Now, the other thing I'll mention, because I always forget to mention this, is that if you look in the GoToWebinar interface, you'll see that there's a handout which is our 100 terabyte benchmark handout. So that is a case study or white paper that covers one of the sort of proof of scale exercises that we did. It was actually for an event last year. And it basically talks through how we've proven out the pretty much linear scalability of Humio and actually run it at scales up to 100 terabytes a day. Some of our customers have subsequently exceeded that themselves in their own production environments, but it's still a good piece of information to have. So let's get started. So what you're actually looking at on my screen at the moment, this is the Humio website. So I'd expect you guys to have found this already. That's almost certainly why we're talking. There's a few resources on here that I want you to be aware of. So obviously if you've signed up to the Humio cloud service, you'll find your login link up here. The other thing that you're going to want to have access to is obviously some of the pricing. So as you start taking on board what we're going to be telling you about cost of ownership, and as you start exploring the product, you're going to want to understand how much it's going to cost. You can use this TCO estimator at the top here to get a pretty good idea of what total cost of ownership is going to look like, and then you'll find the pricing summary down towards the bottom of this page. So we're trying to put all the information out there. There's no complexity in getting hold of this pricing. Feel free to come and find that on our website directly. Now, as I said, you're here. We're talking because you've shown an interest in the product, as in signed up for a demo, created a cloud account, something like that. So there's a couple of resources that I really want to bring to your attention. The first one is going to be docs.humio.com. This site contains all of the reference material that you need as a user of the platform or as an administrator or someone who's actually responsible for installing and configuring the service. And the way we actually organize this information at the top, so you've got all the details you need around installation. We offer quite a few different modes of installation of the product. So we talk about things like single node and cluster configurations. We would refer to these as bare metal installs, but you can go onto a VM, that sort of thing. We provide a whole load of Ansible scripts for building out a cluster very, very quickly. We support that across, you can use that across really any environment. We've then got some cloud service specific content as well. So if you're operating in AWS, you're going to find the AWS specific information here. That's going to help you take CloudFormation templates, that sort of thing, get up and running extremely quickly. And then for those of you using sort of modern cloud native technologies like Kubernetes and Docker, you're going to find the documentation for that as well. Now, for my own purposes, when I'm doing development work with Humio and just wanting to test stuff out, I actually go for the Docker deployment just because it's so simple. It's really, really easy to run through the Docker setup and actually get yourself a Humio instance running. The steps are very, very straightforward. The configuration that you need to do is very, very straightforward. And then it's obviously that single Docker run command to actually get Humio up and running. We'll take a bit of a look at the product as well in a minute. A couple of other resources that are available to you. And in fact, one thing I forgot to do at the beginning of this presentation was actually introduce myself. So my name is James Mountfield. I'm actually the principal solution architect for Humio in EMEA. And if you want to talk to me after this session, or as you start using the product, really the easiest way to do that is to join us on our public Slack channel. So meet Humio on Slack. If you actually come to community.humio.com, you'll find that you can register here. It'll create you an account on the Slack channel. You'll find me on there. You can just go into the general channel and start asking questions. We're really trying to build as much of a community there as possible. We are getting to that point. We've got enough momentum there now that we've got customers helping each other out directly, but you actually have most of the engineering and solution architecture team on that Slack channel as well. So if you don't want to put your questions into an email, you don't want to risk talking to a salesperson, feel free to come to that Slack channel, and we can interact with you pretty directly there as well. So let's have a little bit of a look around Humio, and then we're going to dive into a couple of specific points on the content as well. Now, this is our demo system, so actually anyone can access demo.humio.com. You can sign up with any of those sort of social logins that you saw as we came through here. And we actually, for the demo purposes, we take live streaming data off of the GitHub API. It just provides a decent data set with a certain rate of activity, and it's real live data. And what we're actually looking at here is what we call a dashboard. Dashboards are that human visualization for data. So you'll see that if we look at the dashboards, there's actually quite a few in this project, and it's that real-time representation of this information that you have in Humio. So this is your information radiator. This is your situational awareness screen. No matter what data you're bringing to Humio, you can get it put up onto a dashboard. So to complement that, we also have machine integration. So instead of building dashboards and looking at real-time data, and just to mention, when we talk about real-time data, we usually are talking about moving this data across the cluster within a few hundred milliseconds. It really is real-time. And if you compare that to products based on things like Elasticsearch, you're typically going to see 5 to 10 minutes between data becoming available and actually being represented in search results and dashboards and that sort of thing. In Humio, we count it in milliseconds. So dashboards are the human interface. Alerts are your machine interface. So again, you use exactly the same sort of queries, and alerts allow you to build that continuous insight based on whatever you want to do in a Humio query. You then generally set some sort of threshold. So we're going to look for this number going above 200, and then we link that to what we call a notifier. So notifiers trigger out webhooks and all that sort of thing. So these are the two sort of key points of use of Humio. You've got your dashboards, where human beings come in and get the information they need, and then you've got the alerting system, which is where Humio starts polling out to external systems, notifying a ticketing system, notifying your security devices, whatever you need to feed that information. Now, the third screen that we use is this search screen. This is your sort of analyst's view of the world. This is where you're going to come to do an investigation. You're going to start looking for particular fields, particular attributes of data, and start joining that information. And you're going to be looking for something specific here. So this is your sort of day-to-day analyst view. And what's really interesting is it's very easy to come in here and take a particular query, run it, start seeing results, and then you can populate that stuff onto a dashboard. Actually, this process of building those dashboards is really very, very simple. Very much sort of point and click to help you build the queries, help you select those widgets and put them into a dashboard view. This is what we're aiming for as part of Humio. Now, what actually comes out of this, and when we run through this as sort of a full demo, the questions that come up at this point is how do I start getting my data into Humio? And this is the bit that I actually found quite difficult when I first started using the product. It's really one of the main motivations I had for setting up the, we have for setting up the quick start session. So let's come back a step and take a look at this instance. So in this particular instance of Humio, we've got quite a few repositories here. This cluster is actually holding over 200 gig of data. And interestingly, it's only using 16 gig of storage to do that. So Humio gets its performance, gets its infrastructure footprint through very aggressive compression. It's also how we get our, the speed of search. Don't think that high compression means things have to go slowly. For Humio, that's what drives the speed here. But how do we actually get this data in to the product? So as I said, everything here is organized into repositories. If we actually go into a repository, that's always nice on the demo. That's because it's locked me out of the background. That's fine. Okay, if we actually go into a repository and look at the settings, under ingest, you'll see this thing called API tokens. And this is the bit that was probably the hardest thing for me to understand when I first started using Humio, is how do I send data into that repository? We saw our list of repositories. These are the organizational unit where you put your data. These are the organizational unit where you build your dashboards, where you bring your users into that data set. But how do we get the data there? So what we actually do is we use these API tokens. And API tokens exist within a repository. So we're still in our Windows servers repository here. And we can create our new token. So let's call it quick start, create a token, and let's put it in here. And now we have this unique token. You can copy that down if you want, but I'm going to delete it in a minute. Now, what happens is for all the different points of integration we have, you usually have to provide some sort of key or password or something like that. And you use this token as that key. And that is what builds the relationship between incoming data and this particular repository. Now, what we can also do here is we talk about assigned parsers. This is actually where we tell Humio how to deal with that incoming data and whether we need to manipulate it in any particular way. And then most importantly, how we go about extracting the timestamp for that information. That's the one thing that you really want Humio to understand about your incoming data, is extracting timestamps and putting the events in the right place. So just a reminder, when you start bringing data into the service, you want to put data into a particular repository. It's done through these API tokens that exist within a repository settings. Let's get rid of that. So I'm just going to go. Okay. Now, the other thing about bringing data in, and this is where Humio starts to be a little bit different to some of the other technologies you may be used to, is we don't actually provide a data collection agent for very good reason. So Humio is a relatively young organization. This is very modern tech. You would not, in this day and age, I don't think reasonably, go out and build a new collection agent. The world does not need more collection tools, in my opinion. And Humio, we understand the majority of our customers usually have technology in place and are looking to migrate to something that is better performance, gives them more value from their data, and hopefully costs less to run overall. So Humio actually took a bit of a different approach. So what we did around data collection, let me go back to the documentation. We talk about ingesting data. What Humio did around data collection was not build an agent, but actually we emulate the Elasticsearch bulk API endpoint, and we emulate the Splunk HTTP event collector endpoint, as well as providing our own API. So that means we're actually out of the box compatible with pretty much every Elasticsearch and Splunk collection technique that exists today. There's a few exceptions, or you need to be using open source versions of them. But you can take things like the Beats products and stream that data into Humio. That's no problem. You can take Logstash. You can take things like FluentD that have Elasticsearch output plugins, and it will all just work out of the box with Humio. There's a few other examples that are pretty good. So let's say, for example, you're on AWS and you're collecting container logs. Well, the AWS Managed Container Service has a Splunk log output option. You can actually configure that to point directly to a Humio server, and it will work just the same. So this gives us a huge advantage when it comes to replacing existing tech. And it also, as I said, gives us access to that whole ecosystem of data collection agents. And there's one other one on here that I want to mention specifically, and that's Vector. So Vector is a data collection tool. It's actually a new tool. I said, why would you build a new tool? But these guys have done it. This has been built to be an extremely sort of high performance, parallelized, extremely efficient data collector. We have a customer that's running this on a particularly small instance, and we've seen them put 10 terabytes a day through a single Vector agent. So, this is a really good data collector. Really in summary, I'd say that if you've got an existing estate of data collection and you want to integrate with that, Humio can do it. If you're looking for recommendations or you have sort of a greenfield project that's going to be building something from scratch, I would look at things like Vector. I'm also a really big fan of FluentD and FluentBit. They've become the de facto data collectors for cloud native technologies. They obviously integrate really nicely with Humio as well. So that's kind of the story around getting data in. There's a few other options as well. So we have our own ingest API. So if you want to stream data directly into Humio, you can do that using our own API as well. And then finally, we have what we call ingest listeners. So ingest listeners allow you to do things like set up a syslog port. So if you want to bring Humio into an existing syslog architecture, you can do that. If you want to stream in NetFlow logs over UDP, for example, we got here, you can do that as well. It's a little bit more, this is a little bit more awkward because it's actually quite hard to secure these connections. This is quite a difficult thing to set up securely. My recommendation would always be to actually take something like FluentD and Vector and move it close to the source of that data, and then transmit your data across the network in something a bit more secure over HTTPS, something like that. But the options are here. If you're inside your environment and you trust it, then you can use Humio in that way as well. Okay. What else are we going to cover? Yes. So let's go back to Humio and have a bit more of a look around. So why would people buy Humio? You're going to have read in all our marketing, we talk about doing things faster, with less resource, etc., etc. Now, this is one of the things that's always very, very challenging. I quite often have to present demos of the product to people immediately following a sales presentation, and our sales presentation very much goes along the lines of, this is going to cost you 1/10 of what you're paying for today. It's going to be 10 times faster, and it's going to use 10% of the infrastructure. And generally speaking, those claims are extremely difficult to believe. People that are used to running tools like Splunk and Elasticsearch are used to thinking that if I bring 1 terabyte of data to that environment, I'm going to use 1 to 2 terabytes of storage. I'm going to need 5 to 10 servers for every terabyte a day of data that I'm dealing with. I'm going to need massive amounts of storage, et cetera, et cetera. Humio is not like that at all. We actually, as I said, we get a huge amount of the performance of our product from highly compressing that data. We've used some pretty sophisticated compression algorithms, one of which was developed by someone at Facebook. And what we can do is start compressing down at these sorts of rates. So this cluster overall is doing about 13 to 1. I can actually see the events from these Windows servers are compressing at nearer 40 to 1. I have seen Windows event logs compressed down as well as 80 to 1. And what that really means is that we can start representing a huge amount of data and use a relatively small amount of storage. Humio actually, in almost all cases, is more efficient with its storage than if you just took your raw data without any enrichment or metadata and compressed it using LZ4 or gzip or whatever you use. Humio generally uses less space than that. It does vary depending on the different data sources. If you send a lot of randomized base 64 strings, they don't compress very well, but they don't compress well in anything. But Humio is very, very efficient on that compression. And as I said, that gives us really good performance, because if you want to scan across the last 90 days or however long this data set represents for the Windows logs here, we've only actually got to move 2 gig of information off the disk. So we can very easily hold all of that data set in memory on the machine. We can scan it through it extremely quickly. So what that means is when I open up the search on these events, I'm going to load nearly 1 million events essentially instantly. When I come in here and start, looking at, running queries, this is moving across that 1 million events, and it's essentially instant. This is also running as a live query. So what you're going to see is the results here are actually being updated in real time. That was Humio loading 1 million events from disk, analyzing it and aggregating it based on a key, counting it, and then running that as a continuous live query. And it does this extremely efficiently. So you're gonna find you have a huge number of options to get more value out of the data that you're currently looking at, or that you may want to look at. It's quite a nice query. So again, something a bit more sophisticated. This one is actually doing some IP lookup. So this is now going out and doing external enrichment. Again, you'll see that it's very, very fast. You're getting a really good view on this data. Let's go back to the search screen and we can drill into some of this a bit more. So one of the things that Humio also promotes is that we are index free in the way that we take this data in, and that has a couple of consequences as well. So it means that you pretty much don't have to describe the format of the data that you're going to send to Humio. We'll talk a bit about parsers in a second, but Humio makes everything available for the purposes of search. So if I just took something like work group, ran that as a query across the data, again, we're looking at that sort of 1 million events, scanning through it. That's finding it just because it's a string that appears in the raw message. So that was just a raw string search across every single one of those events. Scanning through nearly 4 million events per second when we were doing that. Suddenly it becomes reasonable to retain data for 12 months, even if you're in the multi-terabytes per day schedule, and you can actually start running these sorts of queries across that whole data set. We actually have a customer that's ingesting more than 100 terabytes a day, retains that data for a year, and they can conduct their queries across that year's worth of data in generally less than a minute, which is ridiculous performance from that sort of scale of data set. Now the other thing you'll see down this left hand side is obviously a whole load of parsed fields. People immediately think these things exist because of indexing, but as I said, Humio doesn't actually do any indexing, and this is all built at query time. So if we want to get into these messages and actually do some additional field extraction, either with regular expressions or any of the other extraction techniques, splitting messages, etc., we can do that after the fact. You're never going to be in that situation where you think, oh, I really want to search on such and such a piece of information, but I forgot to index it when I ingested the data. That just doesn't happen in Humio. As I said, all of this information, is going to be visible at query time. So we can parse and reparse this. We can start adding things to our query to extend it. We could, take one of these fields and actually start, performing some analytics on it and see what results we get. I'll just take all that out. I think it still only gives us one base architecture in use, but you get the idea. And again, the performance of this platform, the way it moves across this data is incredible. Talk about parsers quickly, and then I want to talk to you a little bit about how the cluster is actually built and operates. So I said that we don't have to build indexes. So why do we need parsers? Well, first of all, you don't really need parsers. Parsers are, or parsers should be thought of as a user convenience thing. The one job they do have, as I mentioned, is to reliably extract the timestamp from the data, because that is actually the one thing that we do index from events, is the timestamp, and the reason being that is the criteria that drives every search you do in Humio. You're always searching between 2 points in time, and we want to be able to present results in the right order and all that sort of thing. So we need to reliably extract the timestamp. If we fail to extract the timestamp, we just use the timestamp at the time the event hit hit Humio. Everything else comes down to user convenience. Now, if you're sending logs in JSON format, this is as simple as your parser really gets. So we can parse that event, and then we take that extra step of parsing the timestamp. What that means is when someone looks at this data, Humio already knows how to treat it. So I start seeing results like this. This is, where's my JSON results? Let's take, there you go, results like this. This has told Humio that this is essentially how you treat this data set. Now, on the other end of the scale for complexity, we could take something like syslog. So syslog format has changed. Well, I'm not sure however standardized it ever really was, but syslog format's a pretty complex or diverse format. So we provide a parser for that. And this is one of the more extreme examples. So this is using regular expression named extraction groups to parse standard syslog formats that we're familiar with. And you can actually take any of these and copy them and extend them for whatever needs you may have. There's a few cool things you can do with parsers though, as well as just understanding the format of the data that you're bringing in here. This is the point at which you can start potentially filtering messages that are coming in, but you can also duplicate messages and send them to multiple repositories. You can do things like mask and hash certain attributes in the log, or you could even actually do lookup and enrichment at ingest time if you wanted to. So there's a whole load of pre-built parsers and options of what you can do with them. You also have the choice of doing that parsing at your collection layer. So if you do something like Vector or FluentD, you can make use of the parsers that are available for those, and then just send the events maybe as JSON data to Humio. It's really up to you. Final thing I'll touch on, just because we're here, is about that enrichment. So Humio has the ability to hold what we call files. What this really is lookup tables either in CSV or JSON format that allow you to enrich the data that you find within your search. Really good example here is just Windows event logs have an event code, and then this is the human readable description. So if you wanted to present the top events for a particular node, something like that, this lookup file is going to allow you to do that conversion from event codes to that human readable description. This could just as easily be a threat feed. This could be latitude and longitude information about internal IP ranges, really anything you need it to be. Okay, so that's at the highest level. That's Humio and repositories and that sort of thing. There's a few other really cool features. So rather than repositories, we also have a concept of something called views. So views can be used to build an aggregate of multiple repositories. So just grab a couple of them here, and then you can set different filters on each. So if we imagine we had, say, 5 different project teams that own different applications, but they were all using, they were all web-based applications, and we wanted to build a view specifically for monitoring the web servers, you could have something like that. Then you do, and I think it was Apache, anything like that, and that's going to build you a single view that is an aggregate across multiple repositories, but with a potentially filtered result set. So views are pretty cool as well. But once they're built, they pretty much look like repositories from a user point of view. Now, I wanted to cover some more of the architecture side of things as well. So let's jump over to this administration view. So this is what Humio looks like from an admin point of view. Now, Humio is designed natively to be deployed as a cluster. What that means is that as a modern application, Humio understands what it means to be clustered. It is encouraged in our documentation. We can get a very high level of resilience into the cluster and performance by setting up multiple nodes. So in this case, we've got 3 nodes running. You can see that we've got storage and digest partitions allocated across those nodes. And that means that Humio is going to distribute the workload across all the machines as it receives data and as users write queries. And the good thing is that this clustering was not an afterthought to Humio. It was built like this. So all of the components and tools that you need to sort of monitor the cluster and see what's happening are all available in Humio native itself. So you'll see that the Humio nodes things like the Kafka layer that we use for ingest buffering and within node data transfer, Zookeeper, which is the supervisor of Kafka, et cetera. This is all managed within the product itself. This is also the point at which you start doing things like user and group management. So I mentioned earlier when we were talking about repositories that we've got a pretty rich role-based access model. So you have your list of user accounts, you can start building groups, you can start defining roles, and then you add users, groups, and groups have roles, and roles give you permissions on repositories and Humio itself. Now Humio, to do user management, we expect you to integrate it with something like Active Directory or cloud services like Okta and OneLogin and that sort of thing. So again, it's a modern application in the sense that we expect to integrate with IDPs to do that user management. Now the last thing that you really need to worry about from an administrator's point of view of running this cluster is things like workload and capacity and performance. So we provide that in here as well. So you can actually monitor the cluster in real time and see which queries are running, how relatively expensive they are on the cluster. You can come in here and blacklist particular query patterns. So if you want to prevent people from querying massive data sets and putting too much load on the system, but it's rare that people actually do that. And you can come in here and define quotas as well. So if you start finding that you've got a huge number of users on your cluster and you want to protect the cluster, you can do that as well. And that really is, everything that you're going to find in the Humio interfaces. It's going to come down to your data that you bring in, how you want to present that to your users, what sort of information to make available to them, and how you want to use it, really. Do we have any questions? No questions yet, that's fine. Okay, so there's a couple of other things I want to talk about just while we're here, because the questions we get from potential customers is pretty predictable in some cases. So one thing people ask about, here we go, cluster management, is essentially how do we scale Humio properly? How many nodes do we need? How big do they need to be, et cetera, et cetera. Just find the right page, instance sizing. So we have a really good page here in the documentation around actually sizing the instance, what sort of performance you can expect, et cetera, et cetera. So generally speaking, these rules fit quite nicely. But if you take something like one of these machines from AWS, you can generally support about 1 terabyte a day of ingest per node in your cluster. It says 600 here, but it's generally more than that. What that means is you can start building some really high performance, high scale clusters very, very easily. And Humio, I cannot emphasize enough just how fast the platform is in terms for ingesting data and making that available to search. So if you're considering building a cluster, do get in contact with us as well, but read through this documentation to understand the options that are available to you for how much memory and CPU you need, but also options around things like storage. Now, for example, Humio supports local storage and attached network storage. That's all pretty standard. But we can also offload the storage to cloud bucket storage. So we support GCP and AWS S3. That is actually, generally speaking, a higher performance mode for running Humio than using local storage, except for running a cache on something like NVMe's. So there's a huge number of options with the way you choose to deploy Humio and what storage mechanisms you want to use, and et cetera, et cetera. Okay. So do we have any? You still don't have any questions, which is fine. Oh, yes, we do. Sorry, there are some questions, and GoToWebinar did not make that clear. So quick question, 3 nodes are the minimum configuration for a cluster. How about Kafka and Zuki? Kafka and Zuki installed in the same nodes. So the answer is yes. So when we look at building a cluster, where's my docs link gone? So when we look at building a cluster, I'm just going to go through the single node documentation as the example. Humio will actually guide you through the process of installing the Humio application, Kafka, and Zookeeper onto all of the nodes. Now, well, that means that you're bringing all 3 of those components. The good thing is that Humio itself is a very simple application to deploy. So Humio is actually written in Scala, so we distribute it as a single jar file. All you really then need is to bring a compatible JVM to that environment, and you can run Humio. We do document how to install Kafka and Zookeeper, so you'll see it's all here and it's in the Ansible scripts, etc., etc. But then there are various other options. So if you're already operating your own Kafka cluster, we can integrate with that. Or if you're deploying on things like AWS, we'd really recommend using MSK, which is the managed streaming Kafka or whatever they call it. So some of the cloud providers provide Kafka as a service essentially on top of that. The deployment mode really depends on your usage. So how many of these different nodes do you need? If you want that resilience to the cluster and you want to be able to do things like 0 downtime upgrades or rolling upgrades across the cluster and things like that, then you do need a minimum of 3 nodes. The downside to that, well, it's not so much a downside, but a 3-node cluster is the smallest 3-node cluster you can build is good for a terabyte a day. And some organizations just don't need that. So the other option for the smaller instances is to do something like run it as a Docker container and then use S3 storage and tell Humio that everything about its local storage is ephemeral. And you can essentially run a single Humio node with S3 backed storage, and the actual running instance is essentially disposable. So a lot of options around how you run it, and please feel free to reach out to us and we can talk through sort of your specific needs. A second option, asking if we can use Kibana as a GUI for accessing Humio. So the short answer to that one is no, and that's only because Humio doesn't understand the Elastic query format, which is how Kibana gets its data. That said, there are other options for running different UI on top of Humio. You don't have to use a Humio UI. It's quite practical to use it as a data store on a backend. So what we've actually done, just as a reference example of that, is we've built a plugin for Grafana. So if you're already using Grafana and you want to pull data in that is currently being held and processed in Humio, you can absolutely do that. You'll find the use case documented on our website. And we're looking at those sorts of integrations all the time. I mean, we've built a search operator for Splunk. So those customers that are using some capabilities of Splunk but want to offload the majority of their data to something maybe more reasonably priced, they can do that. But those people that still work in Splunk actually get a search operator that pulls that data from Humio and presents it through the Splunk interface, and that works really well. So you don't have to use the Humio front end. And actually, that reminds me, one of the other things that's worth mentioning here is that Humio has a very extensive API across the whole of the platform. So everything I've shown you in the web interface, you can do through the API. You can run queries through the API, etc., etc. Another question. Can you explain how the HA works in Humio? Do we have to keep an odd number of nodes? That's a good question. So we have the expectation that you build your cluster and that you operate some sort of load balancer in front of it. We have documented examples for, I think, Nginx. Let's just bring this up. Let me find it. There you go. Yeah, so we got some examples for Nginx and Caddy. So if you use either of those, but we have quite a few customers that use stuff like HA proxy or use traditional load balancers or the cloud native equivalent service that works really well. Humio actually provides a health check endpoint as well, so that those load balancers can identify healthy nodes. And as you get into the really big scale deployments, you can make Humio nodes special purpose. So you could dedicate nodes for serving the web interface. You can dedicate nodes for dealing with user queries, for receiving data, et cetera, et cetera. That generally starts kicking in, 20, 30 terabytes a day and upwards, that we'd start building that sort of specialized cluster. So yes, it expects to be behind a load balancer. Now, as for the number of nodes, it depends again on how you've chosen to deploy Humio. So if you rely on things like cloud bucket storage, we actually just tell Humio that everything on disk is ephemeral, and it doesn't matter how many nodes you have taking that load. So we've got again a lot of flexibility on that side of things. Another question. So is the architecture of Humio explained somewhere in terms of how Kafka, Zookeeper, and Humio works together? It's all explained in the documentation, but there's no graphical drawing. We actually use Kafka in an extremely simplistic way, and the only reason we rely on Zookeeper is because you need Zookeeper to run Kafka. We use Kafka as an ingest buffer, and we use it for streaming data reliably and quickly across all the nodes. So let me come back to the admin view. I'll talk about this. So there's a few different things that happen here. So all incoming data is held in Kafka until it reaches a certain scale, in which case we write it out to segment files. And then we actually rewrap and recompress those segment files as the data set grows, which how we get some of the compression rates we do. Kafka is responsible to making that data available to all the nodes, although only some of them will store particular partitions. But it's also how we move around things like global state and config. So when you start doing things like defining dashboards, saving queries, defining repositories, that's all part of the global state of Humio as well. So we use Kafka for moving that data around. We have looked at alternatives to using Kafka. The reason being, we're using about 2% of what Kafka can really be used for. But the reality is that Kafka is actually pretty lightweight, it's pretty easy to install, and it works fantastically well. And internally, the Humio coordinates, they replicate data among themselves. Yes. So you can actually choose exactly how the data is balanced between the different nodes. And one of the things that happens is that you can come in here directly and edit actually where the different partitions go, and you can extend the number of partitions. You have the controls, and this is what I was really getting at when I said that everything about running the cluster is available in here. You can actually control things like draining a node, moving all the data off it, if you're going to take that node out of service. If you change these partition rules, it only applies to future data. So you actually then have a dedicated option to rebalance data across the cluster. The reason that we don't do that automatically is because that could be hundreds of terabytes of data that's used. Question about compression used by Humio. It requires more CPU. Any comparison with Elastic in terms of similar data sizes and cluster hardware requirements? So the general rule for comparing Humio with Elastic in terms of storage requirements is that Humio will use less than 10% of the storage required for Elastic under all the same conditions. So if you want a replication factor of 2, so that's data stored on 2 nodes, and you're going to use Humio rather than Elastic, you just divide the storage requirement by 10. In reality, it's probably going to be more like dividing by 20, but as I said, it depends on the sort of data that you have. We've done a lot of competitive analysis again against things like Splunk, because Splunk is more efficient than Elastic, but not as efficient as Humio. And we know that even if you run Splunk in the most efficient mode, and you make a lot of compromises like removing indexes and all that sort of thing, Humio is still a significantly smaller infrastructure footprint. In terms of the rest of the infrastructure and things like total CPU capacity and memory, we would typically expect that for a 100 node Elastic environment using the same type of nodes, we would reduce that down to probably 10 Humio and Kafka nodes, so a tenth of the infrastructure. In Splunk, that's probably going to be more like 15, because again, Splunk's a little bit more efficient than Elastic in the way it does this, but it's still massive infrastructure savings. I mean, we had a customer recently that, you know, they're spending $6 or $7 million a year on running Splunk in AWS, and, you know, we'd take them down to more like 900K. So you can do a lot with that 5.1 million you're suddenly saving. The other thing it does, though, is it starts to open up a whole load of, you know, additional possibilities of actually holding much more data, allowing many more users to come in, and then we avoid some of the silly limitations that we see in the competitors' products. So things like continuous live background queries. You know, Elastic basically just doesn't do it. I mean, alerting out of Elastic is pretty terrible at the best of times. Certainly not going to get down to that sort of millisecond time range for alerting. Splunk side of things, you can do it, but every background continuous query, you know, occupies an entire CPU core. So what we find is that you again get customers spending millions of dollars every year, and they can only actually run, you know, 100, 120 continuous queries on their data, and that's supposed to meet the needs of, you know, the ops teams and the security teams and everyone that wants to have that real-time alerting. In Humio, you know, we have a couple of customers that are running, you know, 1,000 queries continuously in the background on Humio, and we're much more efficient at the way we do it. You know, we essentially build a finite state machine. When you save the query, we backfill it, and then it only sees that incoming streaming data, and it just uses much less resource. Okay, I've got another question. Loads of questions today. I have a working FileBeat configuration that produces JSON, which is ingested into Elk without any issues. If I switch output to Humio URL using JSON parser, the result indicates the parsing has a failure. So we can definitely help you look at that. The one other thing that you need to keep an eye on in that situation as well is that the version of FileBeat that you'll download from the Elastic website actually tries to do a license check. So you need to make sure you're running the open source version of FileBeat. Another thing to keep in mind as well is that any data that comes into a Humio repository, and I'm not sure if I've got any with failed parsing, but let's just open this up for context. Any data that comes in here and fails to run through the parser, the data is still stored. It's still here and it's still available. So that means that you can come in here and, you know, write the same parsing expression as part of the search to refine that, and then you can save that as a new version of the parser if you need something special. Probably the most common failure with the default parsing is that Humio expects all data to come in with a UTC timestamp. If you look at the standard JSON parser here, you'll see that it just does a straight timestamp parse. If we now compare it to the syslog one, we'll see that in this case we're parsing the timestamp with a special format, but we're also declaring a time zone. So probably the most common failure mode for the default parsers is if you're sending data in a different time zone to UTC and Humio sees it as a future date. That probably means that you're just going to have to either declare the time zone in the Humio parser or change the parsing settings on FileBeat. It'll be one of those two, and it's pretty straightforward. Okay, so you sent a snippet of the log. Yeah, it's, you know, that, assuming that's valid JSON, which I'm sure it is, it's almost certainly that Humio thinks it's a future timestamp. What you'll actually see, unfortunately, because we don't have any errors in this system, it's not going to show up. You'll see that for any field that fails parsing, there'll be an additional set of fields here called error. So you can very quickly identify messages in your repository that didn't run through the parser successfully, and then there's an error message that gets attached as well. So that will tell you what the exception was when it went through the parser. Next question: any experience with a client moving from Elastic to Humio? What are the potential challenges, things to take into account? So yes, we spend all day moving people from Elastic and Splunk into Humio. So I'll answer the last bit first. So things to take into account. First thing to consider is the fact that, you know, cost of change is non-trivial. You've got really two pieces to consider. The first one being the technical, how do we move the data from Elastic into Humio in terms of the data delivery pipeline. But the second one, and probably the more important one, is what are we going to do with the people and the content that we've already built. And this actually applies generically to any system you're moving away from. So the first thing is Humio's done the absolute best job, in my opinion, of making that, how do we migrate the content or the data pipeline over. As I mentioned when we were talking about ingest, we emulate that Elastic endpoint, we emulate the Splunk endpoint. So that means if you're using Logstash or you've got Fluentd set up in your Kubernetes cluster using the Elastic Output plugins or anything like that, you can just address them straight to Humio, and that data is just going to come in. So it's pretty much as low friction as possible in terms of the data streaming pipeline. Now, the second piece that is the bigger piece of work is how do we migrate the people and the content? And it really follows a very standard pattern of, any sort of technical migration. I spent a long time doing software development toolchain migration work. So first step is to, take an inventory of what you have, some sort of survey. If you're using Elastic, if you're using Splunk, you can generate reports of, who are my users, what dashboards are people using, what queries are people running, and you'll find that your first reaction might be, we've got 500 dashboards to find, how we're going to move them all over. Actually look at the dashboards that people have used in the last 12 months, and that 500 suddenly becomes 50, and then of those 50 it's going to be 20, 25 that are actually needed day to day. Just as a real sort of guess, it takes about an hour to move a dashboard from one system to another. If you're good at the query language, you'll do it quicker than that, but let's assume an hour. And what's really interesting is that the effort required to implement a dashboard is almost exclusively spent on considering the data you have and considering the layout and type of visualization you want to use. All that work has already been done for you. All you need to do is have the two tools open side by side and reproduce it from one system to another. Something else I'll mention while we're here, when we start looking at things like migration, if you, anyone that's familiar with it, SOC Prime has, not signed in, last pass, signed in. So SOC Prime basically has a marketplace or a dashboard of, I don't have to close this. How do you close this? There we go. So SOC Prime basically has a catalog of threat descriptions. You can actually open these up and view them in all of the different formats, and we've actually integrated with these guys. So if you're doing things like security in Splunk, maybe you're using traditional Splunk with the Security Insights add-on, whatever it's called, you're going to be able to come here and then get the Humio equivalent of these queries. Yeah, that's not a very elaborate query, but you get the idea. So actually translating between the Splunk query and the Humio query, for security use cases, a lot of this has already been done for you. You've got a huge amount of example content here, as well as the stuff that Humio can provide. The other thing I should mention, and this is going way longer than I normally like to run this session, is that for customers of a certain scale and upwards, we actually offer some enablement as well from our professional services team. That's included in the setup. One question, I think that's a bit more of a one-to-one question, but basically someone's been struggling for a while to get this up and running. What's the best steps to resolve getting Humio running? So if you want real-time feedback and you don't want to get too formal with emails and meetings, come and find us on the Slack channel. Just jump into the general channel and raise your hand and say, I need some help, or feel free to find me personally and we can have a chat. The other option is that having downloaded Humio or accessed the site, you will have Humio emails from our sales team. You reply to any of those and just say, I need a bit of help, and we'll set up a meeting. We'll get on a Zoom call and we can help you through it. It's no problem at all. Okay, so assuming that there's no more questions, I think I covered pretty much everything that I'd want to cover on this session. I just really appreciate everyone joining. I hope this was helpful. As I said, the intention was to give you a bit of a shortcut into finding these resources and understanding how the different parts of Humio work together. I hope we did that. So, good luck to everyone, and please give us a shout if you have any problems at all. Thank you.